Hi everybody, we are going to talk about quadratic functions today, and specifically what we're going to cover is revenue word problems. We're only going to do one, but it should be enough to get you going. Other videos will cover more examples. So revenue word problems are all more or less constructed the same way. Here's an example. So let's say that we sell t-shirts for a fundraiser, and we sell them for $20 a piece. And every year we sell 1,200 shirts. That's about how many we sell. So revenue is defined as the number of items sold times the price per item. Okay, it's not profit, something different. We won't worry about that. We just want to figure out what's the highest revenue that we can possibly make here. So what people have been telling us is they've been saying, you know what, those shirts are really good quality, you could sell them for more than $20. But we also recognize that if we sell them for more money, fewer people will buy them, so we're a little bit wary there, okay? So we have a survey, and we find that for every $2 increase in price, we're going to sell 60 fewer shirts. So what's our maximum revenue? Well, that's what we want to figure out. So we want to figure out what price should we sell them at to maximize the revenue. So here's how I teach this. Your revenue historically has been 1,200 times 20. So 24,000 has been your historical revenue. So if you decide to sell the shirts for $22, the number of shirts you sell will be 1,140. Okay, if we sell 1,140 shirts and we sell them for $22 each, we will have revenue of $25,080. So that's already more than $1,000 that we've been taking in up till now, okay? What if we decide to sell them for 24? By the way, this isn't how you do this, okay? I'm just showing you kind of the process of getting started, and so you can understand what's going on. So if we sell them for $24, our survey indicates that we'll sell that many shirts, and that will give us a revenue of $25,920, and so on. So this will keep increasing until we reach a maximum revenue, and then it'll start to drop again, because then the price will be so high that, you know, people will, it really affect how many people are buying them. So what's the maximum? Well, here's what you want to do. You want to set up your revenue equation like this. So what we're going to be doing is completing the square, which is the subject of another video. You can have a look in the playlists. We're looking for the maximum revenue. So we're going to be looking for the vertex of this quadratic equation that we're going to build. Here's how you build these. Write what has historically been done in brackets like this, and just give yourself lots of room. So the 1,200 times the 20. Now what we want to do is write one iteration of this process over here, but we want to use these numbers to do it. So how do we write a value of 1140 using 1,200? Well, we have to go minus 60, right? That is 1,140. And how do we write 22 using 20? Well, we have to write plus 2. Okay, so here we have 1140 times 22. So write one iteration of the situation, whatever it happens to be. And then when you've got that, just pop x's in beside those numbers. That's your function, okay? Now we have to multiply this out to get it into the general form, because we're going to have to complete the square. So 1,200 times 20 is 24,000. 1,200 times 2x is 2,400x. Those two together make 1,200x. And those two together make minus 120x squared. Because we're looking for a maximum, your leading term has to be negative. Otherwise, your graph doesn't open the right way. It opens up, not down. Okay, it has to open down. Next step is we're going to rearrange these terms and bring the two middle terms together. So when I bring those two together, I get 1200x, and then this is at the back is my 24,000. Okay, so be careful with these calculations too. Use your calculator. I've done this question about 1,000,000 times, so I know the numbers. But make sure that you use your calculator, especially with revenue questions, because there's a lot of zeros and it's really easy to get it wrong, to drop a zero somewhere and then your answer won't be right. So now it's in the general form. Now we're going to complete the square. So we're going to take out the 120, because remember, anything that you have in this term has to come out, and it will also have to come out of this term. So that's going to be minus 10x. When you're completing the square for revenue type questions or for farmer's field questions where you're looking for a maximum area or maximum revenue, this always has to be a minus here, always, because you're going to be moving into positive x territory. Okay, so if this is a plus when you're doing this, something's wrong. Okay, so now you're going to put your plus sign, because it's always a plus sign, remember, and you're going to push that constant together with sign to the outside. Then you're going to take this number, you're going to divide it by 2, you're going to get a result and square that result, and that number goes here. 25 times 120 is 3,000. Okay, I've just done this question a lot, so I know the number. That's minus 120, and that's always plus. So if when you're completing the square, if the number that you're pulling out in front here is negative, you're going to be adding this number. And if the number that you pull out in front here is positive, you're going to be subtracting that number. And you're always going to remember that if anything is here at all, you need to multiply it by that for that balanced number. Now we're adding revenue, so it makes sense that this number gets added. You know, quite apart from the fact that we have to add it because this is negative. So we've got a minus 3,000 here, which means we have a plus 3,000 out here, okay? All right, then negative 120 x minus, because there's a minus there, half of that number or the square root of that one, take your pick, collapse the outside numbers, and we get 27,000. Now, a lot of students have a really hard time at this point. They can get here, but then they just don't know how to interpret the answer, okay? Your answer is kind of in here. It's kind of in the brackets. So let me erase this part, and let's see what the graph looks like. Okay, so if you can't figure out what x represents in these types of questions, you will not get the question right in the end, okay? There'll be some part of it you'll answer wrong. In this particular question, x represents the number of $2 increases, okay? And you're going to look for clues in the wording of the word problem for every $2 increase, for every 10-cent increase, for every 5-cent decrease, for every week the farmer leaves the potatoes in the field. That's what your x variable will represent. So I'm just going to put here number of $2 increases. Okay, so your graph is going to look something like this. Now, what does this point here represent? How would you explain that to someone? If you were at the library and a 10-year-old kid walked up to you and asked you to explain that, what would you say to them? What this point represents, this is your y-intercept, right? And it's this value right here, because this is your general form, and in the general form, that's your y-intercept. It actually represents the revenue, okay, because that's what you're graphing. That's what the function is all about. It represents what your revenue is if you do not increase the price. That makes sense. If there is 0 $2 increases, you're still going to make 24,000. You'll make what you've always been making all along. Now what this tells us is that there should be 5 $2 increases, because the vertex is 5, 27,000. Okay, remember this is 24,000 right here. And then if X were one $2 increase, remember the amount was 25,090, was it? Okay, and that's going to be right there. And if it was $2 increases, we'd increase revenue to that point. $2 increases, we'd increase revenue to that point. 4 $2 increases, it would be here. And finally, at 5 $2 increases, there's our revenue, which would be 27,000. So if there are 5 $2 increases, what's the price of the shirts? So if the shirt used to cost $20, we're going to add $10, and we're going to be selling the shirt for $30. Now, how many shirts are sold at that price? Well, if X is 5 in here, this represents price, then X is going to be 5 in here as well. So 1200 minus 60 times 5 is 1200 minus 300. 60 times 5 is 300. 1200 minus 300 is 900. So we're going to sell 900 shirts at $30 each. And that's going to give us revenue of 27,000. And if that's not the number that you see here, then something's gone wrong, okay? So this is how all of these revenue questions are structured. Again, look for one iteration. This here is the value of whatever written inside the brackets here without that X there is 1140. And the value here is 22. That's one iteration of this situation, okay? For every $2 increase in price, we'll sell 60 fewer shirts. That means if we sell the shirt for $22, we're going to sell 1,140 shirts. And as a result, 1140 and 22 are the numbers that we want to illustrate using 1220, and then just pop those X's in beside it, okay? So, quick video, hopefully that helps. Stay tuned for more examples coming up, and thanks for watching. Okay, bye-bye.